frequency distribution of grouped data. Now we have a question in front of us, and then we are going to solve this question. Now the table below shows the distribution of marks obtained by some students in an examination. Find the mean, modal class, mode, median class, and median for this distribution. So here we have the marks, that is the mark interval, and we also have the frequency, that is the number of times that numbers from a particular interval occurs. So for instance, between 1 and then 10 we have 2 occurrences. Between 21 and 30 we have 12 occurrences. Between 51 and 60 we have 7 occurrences. And then between 71 and 80 we have only 1 occurrence. Now we are going to find the mean, modal class, mode, median class, and the median. So first of all, let's find the sum of f. Now to find the sum of f, or the sum of frequency, we need to add up all the frequency values. So let's do that together. So we have 2 plus 5, that is 7. 7 plus 12 is 19. 19 plus 14 is 33. 33 plus 15 is 48. Plus 7 is 55. Plus 4 is 59. And then plus 1 is 60. So sum of f is 60. So what this primarily means is that 60 students took the examination. So after finding summation of f, now let's talk about the mean. Now to find the mean, we know that the mean is given by summation of fx divided by summation of f. Now we know that summation of f is 60. So we need to find summation of fx. Now this is a grouped data, and so we can't find the exact mean value. Now this is because we don't know the individual values that occurred within a particular interval. So for example, for this interval 1 to 10, we have 2 occurrences. However, we don't know the exact values within this interval that occurred. All we know is between 1 and 10 we have 2 occurrences. So because of that, we can't find the exact mean. However, what we need to do is to find the midpoint. So let's find the midpoint, and that's going to be the x values. So to find the midpoint, we need to find the average of the lower limit and the upper limit of a particular interval. So for the first interval, that is 1 to 10, we have 1 plus 10, that is 11, and then we divide by 2, so we get 5.5. And then for the second interval, we have 11 plus 20, that is 31, divided by 2 is 15.5. 21 plus 30 is 51, divided by 2 is 25.5. So you can guess the trend. So we can add 10 to the next one to get 35.5, 45.5, 55.5, 65.5, and then 75.5. Now we have the x values, we have the f values, so we can find fx. So let's find the fx values. So basically we are going to multiply the f values by the x values. Now 2 times 5.5 is 11.0. 5 times 15.5 is 77.5. 12 times 25.5 is 306.0. 14 times 35.5 is 497.0. 15 times 45.5 is 682.5. 7 times 55.5 is 388.5. 4 times 65.5 is 262.0, and then 1 times 75.5 is 75.5. So let's find the summation of fx. So it means that we are going to add up all the fx values. So 11.0 plus 77.5 plus 306.0 plus 497.0 plus 682.5 plus 388.5 plus 262.0 plus 75.5 gives 2300. So we have summation of fx to be 2300. Now that we have summation of f and then summation of fx, we can find the mean. So now let's find the mean. So we have summation of fx to be 2300, and then summation of f to be 60. So 2300 divided by 60 is 38.33. So this happens to be the mean. Now let's find the modal class. So the modal class is the class or the interval with the highest frequency. Now let's come back to the table. You realize that the class or the interval with the highest frequency is 41 to 50, because we have values within this interval occurring 15 times. So we have the modal class to be 41 to 50. Now let's find the mode. So the mode is given by the expression LCB, which is the lower class boundary, plus delta 1 divided by delta 1 plus delta 2, or multiplying the class size. Now because the lower class boundary is a requirement in order to find the mode, we need to find the class boundary for each interval. So we are going to create another column for the class boundary. Now to find the class boundary, we are going to consider one interval and then the next interval. So if this is our first interval, then to find the class boundary, we are going to subtract the upper limit of the first interval from the lower limit of the next interval, and then we divide by 2. So basically it is 11 minus 10, which is 1, divided by 2 is 0.5. Now we are going to subtract 0.5 from the lower limit and add 0.5 to the upper limit. Now 1 minus 0.5 is 0.5, and then 10 plus 0.5 is 10.5. So we are going to do same for the next interval. So 11 minus 0.5 is 10.5, and then 20 plus 0.5 is 20.5. So for the next interval, 21 minus 0.5 is 20.5, and then 30 plus 0.5 is 30.5. So you realize that the upper boundary of an interval is the lower boundary of the next interval. So we can repeat this same action for the next intervals. So this becomes 30.5 to 40.5, 40.5 to 50.5, 50.5 to 60.5, 60.5 to 70.5, and then 70.5 to 80.5. So these are the class boundaries for the various intervals. Now back to the formula, back to finding the mode. We are to find the lower class boundary considering the modal class. So considering the modal class, we are going to take the lower class boundary. Now this is the class boundary of the modal class. So the lower class boundary is 40.5. So we write 40.5 plus, now delta 1 is the modal frequency minus the frequency value preceding the modal frequency. So that is 15 minus 14. So this is delta 1. So let's repeat the same for the denominator. And then for delta 2. Now delta 2 is the modal frequency minus the frequency value after the modal frequency. So that is 15 minus 7. So we have 15 minus 7. And then all this multiplying the class size. Now the class size is basically the difference between the class boundaries. So let's pick a class boundary like 0.5 to 10.5. So basically we want to find the difference between these two. So it is 10.5 minus 0.5, which is 10. So it means that the class size is 10. So we are going to multiply this whole thing by 10. So we have 40.5 plus, now 15 minus 14 is 1. And then 15 minus 7 is 8. So we have 40.5 plus 1 over 9 times 10. So that is 10 over 9. So when you add these two, you get 41.61. So this is the mode of the distribution. So after finding the mode, we can find the median class. Now we know that the median is the middle number. So to find the median class, we are going to use the formula 1 over 2 times the summation of f, th, describing the position of the value. So we have 1 over 2 times, now summation of f is 60. So times 60 th, which is 30 th, describing the 30th value. Now to find the median class, we need to create another column for cumulative frequency. So cumulative means we are going to add up the frequencies. So for this one we have 2. Now for the next one we have 2 plus 5, which is 7. We have 7 plus 12, which is 19. 19 plus 14 is 33. 33 plus 15 is 48. 48 plus 7 is 55. 55 plus 4 is 59. 59 plus 1 is 60. So when you do it well, you realize that the value here and then summation of f should be the same. So this is the column for the cumulative frequency. Now we got the median class to be the value within the 30th position. The interval 1 to 10 occurs from the first position to the second position. We are going to use this to help us find the positions. Now the interval 11 to 20 starts from the third position and ends at the 7th position. 21 to 30 starts from the 8th position to the 19th position. And then 31 to 40 starts from the 20th position to the 33rd position. However, we are looking for the value within the 30th position. So between 20 and 33, we have 30. So it means that our median class falls within 31 to 40. So this is going to be our median class. So the median class is 31 to 40. So now let's find the median itself. So the median is given by the formula lower class boundary plus the summation of f over 2 minus FCM and then FM divided by FM, all multiplied by the class size. So now for the lower class boundary, we are not going to use the value we got for the modal class. Because we are considering the median, we are going to use the lower class boundary for the median class. So let's attend to the table. So this is the median class. So we are going to use the class boundary, or better still, the lower class boundary for the median class. So the lower class boundary for the median class is 30.5. So we write 30.5 plus summation of f divided by 2. Now summation of f is 60, so divided by 2 is 30. So we have 30 minus. Now FCM is the cumulative frequency before the median class. So when we visit the table, the cumulative frequency before the median class is 19. This is the cumulative frequency before the median class, okay, on top of the median class. So that is 19. And then FM is the frequency of the median class. So the frequency of the median class is 14. So we write 14 multiplied by the class size. As for the class size, it's still 10. Now let's simplify. So we have 30.5 plus 30 minus 19 is 11. So 11 times 10 is 110 divided by 14. So we have 110 divided by 14. So 30.5 plus 110 divided by 14 gives 38.36. So this is the median.